In this session, we shall be dealing with the various generations of dentin bonding agents. See, every agent undergoes a certain evolution, and with it, it brings certain advantages and ease to the use of the operator. So, first, I'm going to tabulate everything together for your ease of understanding, and then I'm going to give a brief introduction on each generation as we go further. So, the first generation, see, generations are important. You can only study on the basis of your etchant, primer, and adhesive. All have different varieties. So, see, the best way to remember this is that in all the 7 varieties, there are a few common factors: 4, 5, 6, and 7. Right? See, in the first three generations, in the first three generations, the etchant was basically your 37% orthophosphoric acid. Orthophosphoric acid. In the first two generations, the primer was considered to be not required. So, in the first two generations, primers were not required. The initial adhesive was GPDM, which is basically glycerophosphoric acid dimethacrylate. Glycerophosphoric acid dimethacrylate. But when it came to the second generation, they got replaced by bis-GMA, which is bisphosphonyl aglycidyl methacrylate, and TEG-DMA, which is what triethylene glycol dimethacrylate. Triethylene glycol dimethacrylate. In the third generation, obviously the orthophosphoric acid was the etchant. But when it came to the primer, here you started adding something like 10% citric acid, 10% citric acid, or our friend EDTA. So, EDTA is introduced as a primer in the third generation. Here again, you had the addition of bis-GMA and TEG-DMA. So, you're going to repeat bis-GMA and TEG-DMA. Over here, you also had things like HEMA. HEMA is basically 2-hydroxyethyl methacrylate, and you also had meta, 4-meta. We have all heard this before. 4-meta was 4-methoxyethyl trimellitic acid. 4-methoxyethyl trimellitic acid. When you came to the fourth generation, you started incorporating the adhesive along with this, right? So you already had 37% phosphoric acid, but here you had the additive of HEMA. HEMA was added in the fourth generation. The 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 primer, therefore, was now in the total H generation. So both enamel and dentin were bonded at the same time. Here you had a repeat of what was happening. The adhesive still could be bis-GMA and TEG-DMA. You could have HEMA and 4-meta. So you had various options that were coming over here. In the fifth generation, we discarded that HEMA. Here you had 37% phosphoric acid, H3PO4. It was still the total H technique. It was the first total H technique. And instead of HEMA, you got Penta. And what was Penta? Penta was dipenta-erythritol pentacrylate phosphoric acid. In fifth generation, Penta came into the picture. In the sixth and seventh generation, only one bottle was required. You did not need an etchant, you did not need a primer. Whereas over here, you had one simple thing, that was methacrylated phosphate in water. Methacrylated phosphate in water. And this was basically an acid primer adhesive technology. An acid primer adhesive technology. So we are evolving from three bottles, which is in the first four generations you had three bottles, to the fifth generation where you came to two bottles. Sixth and seventh generation you came into one bottle. So eventually it started becoming easier and easier for a dentist to start practicing. So I hope this element is clear. See, all you need to remember is almost everything till the fifth generation has 37% orthophosphoric acid as acid. In fourth generation, they decided to become a little smart and added HEMA to the mix. Right. When you look at the primers, for the first two generations, primers were not required. Then they added either 10% citric acid or EDTA in the third generation. The fourth and fifth generation was called a total etch technique. Here, the split bottles have changed. Then adhesives. First it was GPDM, then it became BIS-GMA and TEC-DMA. Then they added to BIS-GMA and TEC-DMA HEMA and Fometa. This kept on continuing in the fourth generation. In the fifth generation, they substituted it to Penta. And in the sixth and seventh generation, it became methylated phosphates in water, which gave an APA system. Right? So this is your simplified version of all the generations that were present. Let us look at each and every generation in detail now. So, coming to the first generation, this was between 1950 to 1970 to 1970. Right. So, what happened? Mineral acids were used to etch the enamel. Mineral acids were used to etch the enamel. Correct? Then, dentin etching was then done. Dentin etching was then done. Why? It was then done, but it was thought to be harmful. It was thought to be harmful until who Fusiyama came into the picture. They used GPDM, which was glycerophosphoric acid dimethacrylate. Glycerophosphoric acid dimethacrylate. Now, this guy was a difunctional molecule. So, GPDM had two components to it. The first component was a hydrophilic component, and the second component was a hydrophobic component. So, the glycerophosphate part of GPDM, glycerophosphoric acid part, the glycerophosphoric acid was the hydrophobic component, and the dimethacrylate part was the hydrophobic component. So glycerophosphoric part was the hydrophilic component and the dimethacrylate was the hydrophobic component. The hydrophilic part would react with the calcium ions on the hydroxyapatite. It would react with the calcium on the hydroxyapatite and lead to the formation of the resin tags. And the hydrophobic methacrylate part would lead to the actual resin tags to be formed. These were generally self-cured. They were self-cured. They did not require the requirement of a light, but they showed severe polymerization shrinkage, which and they had low strength, and the dentin resin interface was not very strong. Therefore, this led to the advent of the second generation of cements, of the composite bonding agents, right? So at this time it was clear that composite was going to replace all the acrylic restorations that were given before. So the first system that was used was the NPG-GMA system. The NPG-GMA system was N-phenyl glycine glycidyl methacrylate. N-phenyl glycine glycidyl methacrylate. So NPG-GMA was the first thing that was present. They said that the NPG portion would bond to the calcium of the tooth by chelation. They said that the NPG system will bind to the calcium of the tooth by chelation, and the other part, the GMA part, the glycidyl methacrylate, would then bond and form resin tags. The glycidyl methacrylate would bond and form resin tags. But what happened? This bond was still considered to be low. The adhesion was considered to be short term, and if there was water that was involved, that would lead to the production of hydrolysis, and the entire restoration would come out in a short period of time. This is why when initially composites were placed, they would break and the patients were highly unsatisfied. So, some of the examples of these were Scotch Bond and Clear Fill, etc. If you ask your friends whose parents were dentists, you would realize that they would talk about Scotch Bond, Clear Fill, Prisma, Universal Bond, stuff like that. So, those were a few examples of second generation dentin bonding agents. This was in the 1970s. So, coming to the 1980s, you saw the advent of the third generation. Now, the third generation was the generation which took a serious attempt to deal with something called the smear layer. These guys realized that under the microscopic condition, a layer called smear layer was what was destroying the adhesive properties of the cements. So, what happened? The smear layer was a layer which was found between the enamel and the dentine and prevented it from bonding properly. It was proposed that the spear layer needed to be aggressively removed by the acid etching. Okay, therefore, the bonding protocol was as follows. First, the enamel was supposed to be etched with 37% orthophosphoric acid. Then, dentin needed to be conditioned with milder acids such as acid malic acid. You had to apply the primer separately. You had to apply the primer separately on the enamel and the dentin. Then you had to apply a polymerizable monomer. You had to apply the polymerizable monomer, after which only you could bond the resin. So you see, you had the E, P, and A systems which were separate. This was the etching system. This was the primary system. These two were the primary system, the primer system, and this was the adhesive system. So you needed three bottles. So in here you had a three bottle system with an efficiency in aggressively removing the smear layer. Examples were right now again Prisma was the same, Scotch Bond got a sequel, Scotch Bond 2. Then you had something like Universal Bond, Mirage Bond, all of these were all examples of Gen 3 dentin bonding agents. Then came the early 1990s. The early 1990s, where the fourth generation started to crop up. Early 1990s. They said that there were two pioneering techniques that were developed. The first technique was called the total etch technique, and the second one was called the discovery of something called the hybrid zone or the hybrid layer. Research showed that both enamel and dentine could be etched at the same time without having a problem with the invasion of the pulp. Therefore, it was considered that both of those steps could be combined together. Therefore, the total etch technique was involved where both the enamel and dentine were etched at the same time. Both the enamel and the dentine were going to be adjudged at the same time. The second thing was the discovery of the hybrid zone. So, what did the hybrid zone come into play? So, the first one was the total etch technique where the enamel and the dentine were etched together, and later the significance was with the formation of the hybrid layer. Now, what was this? In 1982, Nakabayashi and Fusiyama, they reported the formation of a hybrid layer. Now, hybrid layer was then defined as the structure between enamel, dentin, and cementum. This was a layer that was formed because of demineralization of what the enamel, dentin, and cementum on the surface and the subsurface, followed by infiltration of the monomer into the exposed collagen mesh of the dentinal tubules. This may sound very complicated, but no. Look at this diagram. I'm going to show you a diagram. So, in a tooth like this, you had the enamel, dentin, and cementum. Yeah, when I etched this, I would etch the enamel, I would etch the dentin. Sometimes I had to etch the cementum also. I had to etch it on the surface as well as the subsurface, the surface of the enamel going below, subsurface of the dentin going below that subsurface of the cementum, and the monomer which I applied over here, then the monomer which I applied over here should invade into the area where the resin tag was formed, and it should invade into the dentinal tubule. It should go into the dentinal tubule. Therefore, I am covering the enamel, I am covering the dentin, I am covering the cementum, and everything is invading these things at the same time. Therefore, the resin tags that are formed will lead to the formation of a hybrid layer within the collagen mesh. Examples of these were all bond 2, Scotch bond, etc. You had the formation of two primers, either the NPG-GMA or the BPDM. And sometimes they could advent the idea of the BIS-GMA, TEG-DMA, and UDMA. Once this was done, it came to the formation of the early 19 mid 1990s, where the fifth generation came in. Here one step bond started coming into technique. For example, visco was an example. The advantage was reduced application steps, less volatility, pleasant color and odor, and a higher bond strength. Then came the current generation, which was in the 1990s, 2000s, etc., where a separate etchant was not required. Two bottle systems were seen. Okay, so in the fifth generation, two bottle systems started to form from the three bottle primary area. Here, etchant and primer was considered to be in one bottle called a self-etching primer. This was called a self-etching primer, and the other bottle contained the adhesive. So you had a E plus P and an A. Till now it was EPA in separate. In the fifth generation, E plus P happened and A was separate. Example was the Optibond Solo Plus from Kerr, Nanobond from Pentron, Clearfill SE bond from Curer, etc. This was the two bottle, two step system. There was also another version with the two bottle, one step system, where liquid A contained the primer and liquid B contained the acid, the phosphoric acid, plus the modified resin. So you had the primer separate, and you had the addition of the etchant and the adhesive together. So you had the primer in one bottle and the etchant and the adhesive in the next bottle. In the seventh generation, which was what we are using right now, all of these were combined. Etchant, primer, and adhesive. All of this was combined into a single product, and that is what we use right now. Especially with the Clearfill S3 from Curer, or the G bond from DC, or Xenophore from Dentsply, or the I bond from Rasgard Kulzer. All of these elements which we use today are currently from the seventh generation system. So I hope the bonding agents and their generations are clear to you.